Hello dear student, this is Nayab, and today we are doing linear graphs and simultaneous equations, chapter 2 of syllabus D, book 2, and we are solving an investigation today, um, which says to solve the linear equations graphically. And today we'll be using Geogebra as a graphing software, and the investigation goes like this. Consider the linear equations 2x plus 3y is equals to 5 and 3x minus y is equals to 2. Using a graphical software, draw the graphs of 2x plus 3y is equals to 5 and 3x minus y is equals to 2 on the same axis. And then find the coordinates of the intersection points. We are given also the values of x and y in the table, and using these values, we are going to plot a graph on the graphing software. So let's get started. We have the interface of GeoGebra here. So let me plot the points B, C, D, and E. So these were the 5 points given in the table. You can see B, C, and D are collinear points. Let's join them. And A, C, E are also collinear points. And both of them intersect at 1, 1. That means this is the point of intersection, and we call this solution set of the two linear equations. Now, this is my graph. The graph intersect at point 1, 1, as you can see here. X is equals to 1 and y is equals to 1. The first one is the value of x, the second one is the value of y. Satisfy the two linear equations simultaneously. So we say that x is equals to 1 and y is equals to 1 is the solution set of the simultaneous equations 2x plus 3y is equals to 5 and 3x minus 1 minus y is equals to 2. Let's go to exercise 2D, question number 1, part A. Using a graphical method, solve each of the following pairs of equations. So we have got two equations, 3x minus y is equals to 0, and the other one is 2x minus y is equals to 1. This can be solved manually by three methods, either by substitution, or it can also be solved by elimination, and the third one is by matrices. But we are going to use a graph to solve this today. But to do the working, I'm going to use the method of substitution. So let's take the first equation, 3x minus y is equals to 0. Take minus y on the other side. So you'll get a function y is equals to 3x. Now replace the value of x with minus 2, minus 1, 0, and 1, and find the respective values of y. Basically, you need only 2 points to make a straight line. But if we have 3 or more points, then you get a better straight line without having any confusion. It is just to double check whether your line is a straight line or not. So if you replace x with minus 2, 3 multiplied by minus 2 gives you minus 6. So if you replace x with minus 1, 3 multiplied by minus 1 gives you minus 3. Similarly, replace x with 0 and you'll get y as 0. Replace x with 1 and 3 times 1 is 3. Now plot this on the graph paper. Take the next equation, 2x minus y is equals to 1. Bring minus 1 on this side and take y on the other side. So the equation will look like this. Y is equals to 2x minus 1. Take the same values of x here and find the corresponding of values of y. By substituting x with minus 2, minus 2 times minus 2 is minus 4, minus 4 minus 1 is minus 5. So replace x with minus 1, you'll get y as minus 3. Replacing x with 0, you'll get y as minus 1. Replacing x with 1, you'll get y as plus 1. So once you plot the graph, it will look like this. And once both of these straight lines are drawn, it will intersect at points -1, -3. So the graph intersect at point -1, -3. The solution set is x is equals to -1 and y is equals to -3. Let's continue doing part B. X minus y is equals to 3 and x minus 2y is equals to 1. Solve the first equation, x minus y is equals to -3. Take minus y on the other side and bring -3 this side. So that you will get the equation y is equals to x plus 3. Now you can see, so there are various values of x here, -7, -5, -3, -1, 3. Basically, why am I taking these values? If you take -1, 0, 1 or -2, +2, you may do that as well. But make sure that all of these values are whole numbers so that your graph can be plotted nicely. It's for your convenience. So you can do trial and error. Basically, you need only 3 points. If you also take 0, -1 and 1 on this side, you'll get a good graph. But then make sure that all of these points are whole numbers. So I'm changing x, taking these values by my own choice. And you can do the trial and error as well. So if I replace x with -7, I'll get -7 plus 3 as -4. So substituting x with -5, we'll get y as -2. Substituting x with -3, you'll get y as 0. Substituting x with -1, you'll get y as 2. And substituting x with 3, you'll get y as 6. Now, this next equation, x minus 2y is equals to -1. Bring -1 here, you'll get +1. And take -2y on the other side, you'll get +2y. Since you have +2 on the other side, you have to divide the equation with 2 on the other side. So you'll get the final result like this. Y is equals to 0.5x plus 0.5. Now substitute the value of x with -7, you'll get -3. If you substitute x with -5, you'll get -2. Substitute x with -3, you'll get -1. And similarly, these two. Once you plot these coordinates on the graph, it will look something like this. And you can see that these two linear equations intersect at point -5, -2. So the graph intersect at -5, -2. The solution set is x is equals to -5 and y is equals to -2. So we stop here and you can try yourself by solving this linear equations on a graph paper. Take a good scale that can best fit the whole graph and make it wide enough so that you can see the point of intersection. Don't take the points too close. As you can see, the points are very, very far away from each other. If you take it too close, you might miss the intersection point and it will look messy. You might find intersecting point somewhere here and it will be difficult to then calculate. So do it far away so that you can easily calculate the point of intersection. So I hope to see you in the next class. Take care of yourself and keep on practicing.